In section 10.6, we'll be focusing on more angle-arc theorems. After watching this video, you'll be able to recognize congruent inscribed and tangent chord angles, determine the measure of an angle inscribed in a semicircle, and apply the relationship between the measures of a tangent-tangent angle and its minor arc. Our knowledge of the relationships between angles and their intercepted arcs leads easily into the next two theorems. Let's take a look at the first theorem. It states that if two inscribed or tangent chord angles intercept the same arc, then, before filling in the rest, I want us to take a look at the diagram and try to figure it out on our own. So let's take a look at this first inscribed angle, BAD. Which arc is it intercepting? It's intercepting arc BD, the yellow one here. Do we see another inscribed angle or tangent chord angle that's intercepting that exact same arc? This blue angle BCD is. Since both of those angles are inscribed angles and their vertices lie on the circle, they each have a measure that is half the measure of the intercepted arc. So the red angle is half the measure of the yellow arc, and the blue angle is also half the measure of the yellow arc, which means that those two angles are congruent. Let's take a look at it from a different perspective. We have this other inscribed angle ABC, which intercepts the yellow arc AC, and we have another inscribed angle ADC, which is the orange angle there, that intercepts that same yellow arc AC. So that must mean that those two angles are congruent. Let's take a look at the second theorem. The second theorem says if two inscribed or tangent chord angles intercept congruent arcs, then, well, I'm going to tell you that this arc PR and this arc TU are congruent. Angle PQR is an inscribed angle that intercepts arc PR, and angle TUS is a tangent chord angle that intercepts arc TU. Since both of the vertices of those angles lie on the circle, both angles have a measure that's half the intercepted arcs. But since the arcs are congruent, that means the angles are congruent as well. Let's talk about angles inscribed in a semicircle. We have this inscribed angle here, ABC, since the vertex of this angle lies on the circle. Let's extend the rays that form that angle so we can clearly see which arc is being intercepted. We can see that arc AC is being intercepted, which is a semicircle since we have our diameter drawn in. We know that that arc must have a measure of 180 degrees. But any inscribed angle has a measure that's half of the intercepted arc. So that angle must have a measure of 90 degrees, which means that an angle inscribed in a semicircle is a right angle. And finally, let's talk about a special theorem about tangent-tangent angles. So we want to think about the relationship between this red tangent-tangent angle and the yellow intercepted minor arc. I'm going to draw in the radii to the points of tangency or points of contact for the tangents. That means that we have right angles that form. And now we've created a quadrilateral. We know that the sum of the interior angles of any quadrilateral is 360 degrees, and we could determine that by using n minus 2 times 180. Those two 90-degree angles account for 180 degrees out of the 360 degrees total, which means we have 180 degrees left to work with within the quadrilateral, which means that the red and blue angles must add up to 180 degrees. But since that blue angle is a central angle, it has the same measure as the arc that it intercepts, which is the yellow arc NM. So we can replace the blue with yellow and say that that red angle plus the yellow minor arc must add up to 180 degrees. And that means that the sum of the measures of the tangent-tangent angle and its minor arc is 180 degrees. We'll pick back up with the second part of the notes in just a moment.